Hello, I'm Brian Fennick. In this experiment we're going to be studying calorimetry using a constant pressure calorimeter consisting of two nested coffee cups with a lid. In part one of this lab we have to measure the calorimeter constant, or the heat capacity in other words, of our constant pressure calorimeter, which consists of two nested coffee cups and the lid. Set up your experiment as follows. So take your two coffee cups and nest them together, then put a magnetic stir bar in them, put it on the magnetic stir plate, and make sure that you turn the stir button on, not the heat button. We have had people in the past accidentally burn their styrofoam cups by turning on the wrong button. Then position your thermometer so that the tip is going to be in the liquid and that it doesn't poke through your styrofoam cups. We've also had that happen. You can turn on your thermometer using the power button on the left side. Next, you're going to obtain 50 milliliters of room temperature water from the plastic jug, and then turn on the tap using hot water. After it gets hot, obtain 100 milliliters of hot water in your beaker. Place the hot water into your coffee cup calorimeter. Record the temperature of the room temperature water in the graduated cylinder. This is considered to be solution B. In my case, temperature is 20.8 degrees. It should remain stable like this because it's at room temperature. Obtain a timer and insert your thermometer into the calorimeter that contains the hot water. Press start on the timer and record the temperature. In this case, 36.7 degrees. Every time the temperature changes like that, you record the new temperature, 36.6, and the time, which was 13 seconds. Wait for the thermometer to change again. Make sure your magnetic stir is stirring in the calorimeter. 36.5 at 33 seconds. Do this until you have 4 or 5 data points. Keeping your timer running the whole time. After you've collected 4 or 5 data points for the hot water, add the cold water to the hot water in the calorimeter and record the time of addition. In this case, 1 minute and 38 seconds. Replace the lid and make sure everything is still stirring in there. Then about 30 seconds after mixing, it doesn't have to be that long, it could be 20 seconds. It's just so you know the exact time, and you've given it some time for it to mix so that it comes to equilibrium. Okay. Record the new temperature, in this case 31.2, and the time, 2 minutes and 8 seconds. Wait for it to change, which it just did, 31.1, and record the time, 2 minutes 17 seconds. Again, wait for the thermometer to change. This could take a while, as your temperature is now closer to room temperature than it was initially. Okay, just changed, and it was at 3 minutes and 5 seconds. Changed to 31.0. Do this until you have 3 or 4 data points after mixing. Now, using the graph paper in your notebook, make a graph that looks like this, plotting the temperature on the y-axis and the time on the x-axis. You're recording the temperature of the solution in the calorimeter, which we called solution A initially, and in this case it was the hot water. So notice that the hot water is changing, is cooling down over time. We do not have a data point at the time of mixing, but we'll make a vertical line at the time of mixing. And then you see the data after mixing is again starting to eventually cool down over time. It may initially have a little bump like this because it hadn't come to thermal equilibrium. We're going to extrapolate the post-mixing data back to the time of mixing and the pre-mixing data to the time of mixing. This one we're going to call TA, and this temperature we're going to call TF. Delta TA is TF minus TA, so you'll notice in this case is going to be a negative number. Delta TB in your calculations will be the temperature of the room temperature water that was in your 50 milliliter graduated cylinder. Delta TB is equal to TF minus that TB, and it should be a positive number. CA for part 1 is 4.17 joules per gram degree Celsius times 100 grams of solution A, since you had 100 milliliters. And CB is equal to 4.17 joules per gram degree Celsius times 50 grams, since you have 50 grams of room temperature. You can then use the equation in the lab manual to calculate C of apparatus, or the heat capacity of your calorimeter. After you've done part 1 one time, carefully dump your solution, which is just water, down the sink. Being careful not to lose your stir bar. Then, as time permits, repeat part 1 a second time so you can average your values. In part 2 of the lab, we're going to measure the delta H reaction for an acid-base reaction. Each group will be assigned one of the acids from the list in the lab manual and one of the bases from the list in the lab manual. It's important that you write down which acid and which base you were assigned. In my case, I was assigned nitric acid and sodium bicarbonate. Using your grad cylinder, place 100 milliliters of your acid into the calorimeter and make sure the stir bar is stirring. Place 50 milliliters of your base into the graduated cylinder. Record the temperature of your acid after it is stabilized. In this case, 20.6 degrees. That will be TA. Record the temperature of your base after it's stabilized. In this case, 21.2 degrees C. That will be TB. Start your timer when you add your acid to your base. Place the lid on your calorimeter and stick the thermometer in there, being careful not to poke any holes in the bottom of your calorimeter. After about 20 or 30 seconds, once you've allowed the solution to equilibrate, you can begin to record your temperature versus time reading. So I'm going to wait till 30 seconds. So 30 seconds after mixing, my temperature is 20.8. Watch for the temperature to change. Every time the temperature changes, record the new temperature and time. Do this until you have 3 or 4 data points. Plot your data in your notebook using your graph paper. Mixing should occur at time 0. Use a straight edge or a ruler to connect your data points and extrapolate them back to the mixing time. This will be TF. You've already measured TA and TB, the temperature of this solution of the acid in the calorimeter, and the temperature of the solution of the base in the grad cylinder before you mix them. You can calculate delta TA as TF minus TA and delta TB as TF minus TB. In this part of the lab, the specific heat of the acid and the base are both 4.05 joules per gram degree Celsius. So the heat capacity of your acid solution is 4.05 joules per gram degree Celsius times 100 grams because we use 100 milliliters of acid. And CB, the heat capacity of your base, will be equal to the 4.05 joules per gram degree Celsius times 50 grams because we use 50 milliliters of base. The C apparatus will be the average value from part 1 of the experiment. The typical value will be between 0 and 30. You cannot have a negative C apparatus. So if the average value of yours was negative, again, you can dump your solutions down the drain since they are now neutral, being careful not to lose your magnetic stir bar. Repeat part 2 of the lab a second time so that you can average your values. For part 3 of the lab, obtain 100 milliliters of HCl. Regardless of what acid you used in part 2, everyone will use the HCl solution in part 3. Put the 100 milliliters of HCl into your calorimeter with the magnetic stir bar and stir it. And put the lid on. Let the solution come to equilibrium and record the initial temperature. In this case, 20.5 degrees. Tear the analytical balance with nothing on it. Then take your piece of magnesium ribbon, put it on the balance, and record the mass. Taking care not to break your magnesium ribbon, wrap it into a small wad and tie it with the piece of copper wire. Drop the copper with the magnesium ribbon into your calorimeter. Replace the lid. Start your timer. Do not record the temperature at this point. Every so often, peek into your calorimeter. See if it's still reacting. We're going to write down the time at which it is done reacting, which is when it's done fizzing. Make sure you've recorded the done time when the reaction is finished. Then, after about 20 or 30 seconds, begin to record the temperature as a function of time again. After you have 3 or 4 data points, plot your data like this again, temperature versus time. Except in this case, we're going to mix at time 0. And we're going to have a vertical line here, which is the done time. Halfway to the done time, we're going to call that half time. And this temperature right here, when we extrapolate our data points back to half time, is going to be TF. We've already measured TA as the temperature of the HCl beforehand. Delta TA is equal to TF minus TA. There is no delta TB in this part of the experiment because we use magnesium instead of a solution B. So that whole term will drop out in your master equation. Again, use the average C apparatus from part 1 of the lab. Use 0 if you had a negative C apparatus. Then calculate delta H of reaction and repeat this part of the experiment a second time and average your 2 values. After cleaning up and returning your copper wire and your calorimeter, your thermometer, and your timer back to their station, then you can do the calculations. It's important that everyone reports their delta H, their average delta H of reaction for part 2 of the lab to your instructor, along with your name, your partner's name, which acid you had, and which base you had, within 24 hours of completing the experiment. This is because the instructor is then going to distribute over Canvas the average delta H values for each acid-base pair to the entire class so that the class can pull that data together to answer some of the post-lab questions.